Hi, Nate Shortsleeve here again. This time I'm demonstrating Orchid. Orchid is an extremely streamlined and simplified 2D game framework which allows for rapid development of two-dimensional and very simple games, the likes of which are, say, Breakout or Balloon Fight. I have here the starting of a gauntlet-style game and the very bare bones of something like Animal Crossing. I'm going to demonstrate these four games here, or the progress thereof, to you in a minute here, but I wanted to explain the basic premise behind Orchid. Anyone who understands object-oriented programming and C++ should be able to make a game very quickly by implementing the game objects, their behaviors, the controllers for objects which would need to be controlled, and the game logic itself for their particular game. That's it. That's all they will ever have to implement in order to make a game. Additional features would probably have to be implemented elsewhere, say for instance drawing very complex shapes or doing routines, which I obviously didn't think of, but I tried to think of every use case I could possibly think of during development of this. So you'll probably see where my thought processes went in a second or two, but the cores themselves are global singletons. I have the audio core, the event core, and the graphics core here. They wrap Allegro. They also use Boost, but those are the two highly integrated libraries that I use, meaning that if I were to replace these three classes, I could port Orchid to any other platform. I would just have to replace these three classes. That's it. So these are wrappers. They're accessible throughout the program. You'll see how they're used later on. But the graphics core and the audio core both load all of the assets within their respective folders. So this is the data folder right here. This has all the assets ever used for all the games. When you're distributing anything which is used by Orchid, or any games made by Orchid, you obviously would want to trim these because we wouldn't want to load all the assets for every game that was in here. This was a conscious decision on my part to load everything when a game is initialized, so that any user who decided to program their game using this framework would not have to keep track of every asset they created and when to load it, when to deinitialize it, I guess unload it, and then we'll have memory leaks or other issues like they can't find it, so the program crashes and all this other stuff. I thought that it would be a good idea to completely streamline that. So anytime someone drops this in, one of these audio files or one of the image files, then Orchid or game using Orchid is loaded. These are all loaded. Everything's loaded. So you never have to worry about something not being there or file name being incorrect, because using Boost I just search throughout the entire folder and then find everything and load it all. So there's obviously the detriment of loading everything into memory, but if you're loading something into memory that you're not going to use for a game, you probably should just delete it from the distribution package. So that aside, my apologies for my designs aside, we can move on to past the cores themselves, which as I said were just wrappers for Allegro. I have things in here like drawing routines for the graphics core. I have map scrolling routines and loading routines and so forth, fonts, displaying. The audio core is much simpler. It's play sample, play music, and stop music. That's it. That's all that's in there. The event core responds to input events by things like joysticks, keyboards, mice, and also system events triggered by Allegro, and I may have some boost in here. But moving on, I'm really moving on this time. We can go to breakout. This is the main.cpp file. In theory, the only thing that anyone would ever have to change here is this line, which identifies the game and the run routine for it. And of course, you're going to have to include the game class. So let's start with breakout here in the Solution Explorer. This is the header file for breakout. This includes the run function and all of the game logic, all of it. All of it exclusive to breakout. There are behaviors to the parent game object class that are inherent to all objects childed or subclassed from it, obviously. But this is all the logic to that game, and you'll see how it works in a second. These are the three objects that I created for breakout: the paddle, the block, and the ball. And obviously, the only thing which would need a controller would be the paddle, because the blocks are just static; they just stay there, and the ball is reactive. So I'm going to run this, and you'll see here it is. There are the blocks. Here's the paddle, and if I push space, there goes a ball. If I push space many times, there goes a lot of balls. But see, I didn't really implement a lot of logic here. I was kind of seeing how quickly I could make a game. I'm using A and D to move left and right. And the sound. Oh, geez, this recording software is really messing up my frame rate. The sound is really distracting, so I'm going to close that. So what you saw, obviously, was collision happening. I was instantiating game entities. I'll start playing it again so that you can see. These balls are reacting to both the blocks and the paddle. Everything was loaded prior to my writing the game logic, so I didn't have to think about that. You'll see here I start defining the block array and creating the blocks. I create the paddle. I register the paddle with the event core as a player, and I add it to the world. Then I start a timer so that I can play, or not play, but display a message to the user at some point. I don't even remember. And then I enter the game loop and start running the game. And when someone pushes the escape key, then this becomes false. This is where that global data class comes in. And this check falls through, and the game's over. That's it. That's all breakout is here. Everything. So you can see that the power of automating and loading everything really allows someone to make a game very quickly. Let's move on. Balloon Fight is another game that I implemented. Well, implemented is a generous word. I created a game with frogs tied to balloons and tried out collision routines which were reactive to the types of objects which were colliding. So this is actually kind of difficult to control, so I'm going to start over. So I messed up my demo here. Okay. I have this frog here I'm controlling, obviously. And I have 4 entities in this world. You can see 4 right there. I have these 2 frogs and I have these 2 balloons. And the balloon, if you look hard enough, you'll see that it's actually like lagging slightly behind, giving the effect that it's just like, I guess, wind resistance or something. Again, I messed it up. I keep doing this. So the purpose of this demo was to display the behavior that if an object interacts with another object, you can determine which type of objects are interacting. So if I collide with another frog, you'll see briefly these 2 frogs become red. The ring around them becomes red because their entity area is colliding or overlapping. The same goes for these balloons. So if a balloon contacts a balloon, nothing happens. If a frog contacts a frog, the frog which is moving its velocity is reversed. It just bounces back. See. But if a frog contacts a balloon, this is really difficult, then the balloon behaves differently from the rest of the entities. It becomes, well, effectively popped, but it still exists in the entity manager. Its behavior changes, and it pushes the frog down as a sort of hack in order to simulate the frog falling. So let's go over to the frog class. This is implementing game logic. It's just implementing game object. It's just a child of game object. Here we go. This is all fairly standard stuff. I'm changing its shape to a circle instead of a default square or rectangle. This is the update routine. This handles drawing and movement. This is actually drawing. Sorry, this is drawing, and this is movement, and this is the parent update routine, which I'm invoking. But this is where the magic happens. This is the collision event, which is triggered. A game object pointer is passed to it. This is the other object that you're interacting with, or that this frog object is interacting with in this frame. It is determining whether it is colliding with this other object, and then it is reversing its velocity. For the balloon, this gets more interesting because it is asking the target object, what is your type? If you are a frog, then play this audio sample, which again did not have to be loaded. I can assume that it's loaded because the game is running, and set my life to popped, which is an integer declared constantly as 1. This prevents the behavior of my life equaling 0 or less, removing myself from the event manager, not event manager, the entity manager, so that I don't get deallocated, so that I can still have this behavior of pushing the frog down. The frog controller is simply implementing the left-right behavior and up and down behavior and so forth. This is start and stop function calls. So WASD allows you to start moving left, right, up, and down. And the balloon fight game, again, very short, 57 lines of code. Just 57 lines of pure C++, nothing else. There's the familiar while loop, the game loop, and then the allocation of the game objects that in theory the user would have written, but it was me. So if I change something very briefly to, like, say, add 3 players instead of 2, you can see after this compiles, I got 3 of these, so I can pop 2 of these balloons and completely dominate the other amphibious floating entities. Okay, so that's balloon fight. And the breakout. Here we go. Animal Crossing. Animal Crossing is one of my favorite games ever. It's very relaxing. Okay, here we go. Yeah. Everybody's got their weird games they like. Animal Crossing here. This is not Animal Crossing, obviously, and I am not using a sprite that I created. I think this is from Pokemon, but you're starting to see here. I'm probably not acting my age. I started out with ambitions to create like a simple Animal Crossing style game, but I never really got past what you're seeing on the screen here, just because of other obligations, and I was doing all of this in my free time, so there were trade-offs that had to be made. But that aside, what you're seeing here is an example of my animation system and input system. You can see here that this little dude, when I push the S key, is walking down. When I push the W key, his sprite animation is changing and his speed is changing. When I push the A key, the same thing happens, but with a different animation, different speed. And the D key, so forth. 4 animations. Here we go. Right? Analog movement, 4 animations. Let's close this for a second, and I will show you. That's my recordings. How many times it took me to get this right. The images are, like I said, they're all in the images folder. I sequenced them in a way that seemed logical to me. So I just named them whatever. This is where you do have to define things, but only once. And once they're defined, you know they work. So I have here the walk down animation, and let's bring this back up, and I'll head over to the walk down animation. These are the 3 files pertinent to the walk down animations, or walk down animation. There are 4 frames in the walk down animation: frame 0, frame 1, frame 0, and frame 2. That's the sequence of the walk down animation. You'll see here 0, 1, 0, 2. That's it. So like left leg, standing, right leg, standing, and then repeat. So you can define the behavior, the frame sequence, and the frame rate in the animation file, which is just a text file, simple text file. You can create completely new animations by using Notepad. Isn't that cool? So the behaviors that you can use are play once, which means don't repeat; bounce, which means you will go to the end of the sequence and then back up, and then back down to the end again, back up, and so forth, like that. Repeat loops. So I go 1, 2, 3, 4, and then 1 again. 1, 2, 3, 4, 1, 2, 3, 4. That's it. That's all the animation does. That's all the animation files. That's all there is to the animation files. They're just text files, and they just become larger sequences, and those 3 properties are the only things that you ever have to define. So if I go to the little Animal Crossing game here, the neighbor object, I assign these 3 animation objects, which probably should have been defined as pointers here. I assign these to the object so that it can reference them, and when it determines that it's walking in a direction, it plays that pertinent animation. And it's very simple. I didn't have to load anything. Again, everything's already loaded, and the animation class actually uses this factory animation thing to add the animations to a manager, so that the animations which are defined are never duplicated. You can just reuse the animation content, because it's all it is C++ at that level. And I'm referencing a collection which has a sequence of frames which eventually get resolved to a map of images here in the graphics core, which means that nothing's ever duplicated, and all of the space in memory is conserved as much as possible, keeping in mind that trade-off that you're loading everything in your directory structure. So one more time, let me put this side by side here so that you can see the let's see, down animation and the images right here. Let me get up there. You can see I should have changed the speed here, but it's going a little fast. You see there's the 4 animations, or 4 frames, and it's repeating. Okay. So the last demo I wanted to show you was an incomplete attempt at something like Gauntlet. Let me head over to the main .cpp file here and run that. Here you'll see that we have map loading. I used tiled, formerly tiled Qt, I believe, to create this map from tile set. And you'll have to forgive me, my computer is not that fast, so this is kind of lagging a bit. I promise it's not the program. You'll have a build available on my website to try out yourself. Okay, so this is a mess artistically, obviously, but you'll see that these shapes here, these squares and circles, are physical entities with debug and drawing primitives, and the rest of these sprites here are just tiles on a map. Oh geez, this is not going well for me. I have to apologize for that. This is not what I expected would happen while recording. But I am automating the loading of the map after it is selected. So the map is a special case. You'll see here. Those are the videos again. Maps. I have here desert, grass, and breakout. I think I attempted to create a breakout map to make that simpler. I'm gonna close this and try it again. Actually, let me show you how this is happening. So here in the run routine that I defined earlier, I selected the desert to load. That's it. All I selected was the name of the file, not including its extension, and I started a timer, which I used to test the timer class that I was developing concurrently with this stuff, and then print some stuff to the screen. I draw I update the level. This allows me to scroll it. So that if I move to the left enough, then the quote camera moves, and I can also draw the level and then draw the entities on top of it. Very simple stuff. Let me try this one more time. There we go. Okay. I think I also have, yeah. So I have spawning here of spells. I created this little dude to shoot spells at other little dudes. You'll see that when they collide, they flash red. That signifies they're actually colliding, and they collide correctly. See, like a shape can collide with a circle, and so forth. You see here the scrolling behavior that's working correctly. Well, it was until this is starting to lag again. I promise you, this is not normal behavior. Feel free to try the download on my website. You should be able to see it under the post that you're seeing this video. So I will not insult your intelligence by trying to tell you where it is. Additionally, I also included I implemented a Lua interface, but found while I was doing it that I didn't really have itemized the function calls which I would need to wrap in the Lua interface, and that would take forever to do because there's so many things I would automate. So I made this mainly so that you can just write your objects in C++ and then write your game in like what 40 lines of code. So that it seems like a moot point at that juncture. I had Mappy support. Oh, this would be a good time to go into the tools that I used. So Mappy was the original map editor that I used. I decided that it wasn't really what I was looking for. It's still a great program, but I decided to move over to Tiled. This is the program. Ooh, that's not working correctly. Let me open up the file that showed you the desert here in maps.tmx. So this is what we're applying here. So I can do something like let's put a row here, and then that's not really a very good happy face, is it? So let's do that, and then I'll save this. We'll run this one more time. I hope I can get to it before it lags out. Come on. Okay, yeah, here we go. And there you see the happy face, right? And it's scrolling correctly. That's good enough for me. So I used tiled and its TMX file formats to spawn the enemies and the player and the tiles and all the objects therein. Let's see. Allegro, obviously, like I said before, I have boost in here. Mappy is deprecated. I have Lua. It's implemented and working, but I only have like one function call implemented. Tile Studio and ASC Sprite, or yeah, whatever, are two programs that are sprite painting programs. One specifically for tiles for maps, and this one I guess for animations. I never really dove deep into these third-party programs, but they seemed like really good choices, and I thought it would be a really just a fun idea to write bat files which would launch each of them. So I have like this tiny little microcosm of a game developer tool set right here in my repository. This has been a long video. This is going on 26 minutes, but thank you for your time if you lasted this long. This has been Orchid.